Hello. I hit go live, so we should be live. Okay, we are live. Hello. Let's just get straight into it. No, nothing asked. This is what I have so far. Oh. That's... Oh, wait, okay, hold on. Let's write some quick code. Let's say A equals to hello world. And then just out A. There we go. We have our tokens working nicely. Let's go into the parser, which I'm writing right now. I think all I need to do is implement it. Not too sure. I completely forgot what I was doing. I'm not gonna lie to you. I think I was coding the factor. Oh, whoops. I think I was coding the factor. I'm not too sure. Yeah, I'm just gonna quickly go over to where is this? I'm looking for where I was up to. I think it was in Lang. Yeah, it was. Okay, in here, parser. Okay. Oh shoot, wrong folder. I completely forgot what I was doing. I have lost my train of thought. Oh no, I didn't even mean to open Eclipse. Oh my gosh, I swear if this... Okay. I'm having to deal with like two things at once right now. No. Oh my gosh, this person is annoying. I may mute them. Anyway. Let's just get back to this code here. Let's do the left and right parenthesis before returning a parse result. So else if token.type equal to the token type of left parenthesis, then we'll register an advancement, and in advance we will call the expression, which we're going to need to register. So this dot expression, which is going to return a node, I believe. We're going to check for errors after we register this. Okay, then we'll see if the current token dot type is the token type of the right parenthesis. Then once again we will advance, returning res.success expression, and then we'll return, we're gonna return a invalid syntax error. let's go ahead. We're gonna detect one of these, then we're gonna return a new invalid syntax error. And we will pass in these, passing in x, or what was it? It was, oh, whoops, not, this is needing to be the token, because that's what we set it as, x. So that should be that sorted. Now we just need in here, if we're not getting an error, then we'll create a parser, passing in our tokens, which was a token list. Then we'll go ahead and we'll say ast equals to parser dot pass. If ast.error, return console.log ast.error. Otherwise, we're just going to console.log ast.node. Okay, so we're getting this because we haven't recognized it, so we'll just enter in math expressions, and this should, where's this coming from? This dot token equals to token. Whoops, yes, I think I forgot that in all of these. Let's just, wrong one. Yeah, I did. That's a big oops. Oopsie doopsie. That was so dumb of me. Now I feel like a big idiot. Okay, there we go. We should probably say ast.node.element nodes object bin op node. Can we say toString? Okay, this is going to require us to have a toString method in all of our functions, which is just going to return the exact same thing, but that's just going to be how it is. We won't need one for the list node. We'll default a toString method just so that we have that. Number node toString. Whoops, that needs to go there. Now, last but not least, our unary operation node, which will return the same thing. So now that shouldn't say that this is incorrect. Oh, whoops. We're gonna need to say token.toString. .toString. We'll add that in later, but we're also going to need to pass in these toString functions to each one of these. Number, we already did that. List, we don't need to do, and we've already done bin operation. So inside of our token, we have the exact same function You know what, I don't care. I'm just gonna call it toString. Can't be bothered. There we go. Done. That is what that looks like if we add in more, like divided by and then, or minus and then a divided by. As you can see, sorting itself out perfectly. Let's move on to the interpreter. The interpreter. We are going to just go on to the interpreter. Did my stream just crash? No, I should. Am I? Oh. No, my stream's. No, my stream's still here. Okay, let's move on to the interpreter with our. No, we are not moving on to our interpreter. We need to get these other nodes in. We need our string node. Sorry about that. Hold on a second. Okay, hello, I am back. Hello, hello. Oop, wrong. Okay, here, okay, hello. Hello, everyone. I am back. I went to go have something to eat. Yup. Yeah. Let's continue. So, with this string node, we're gonna need just a token. We're gonna need only a token. So we'll set the token to the token, the position start, and the position end, then the name, which is just going to be string node, and we're gonna need our toString method, which, come to think of it, we could just say that our require util.inspect.custom function will just return the toString method. We're gonna get our node from this same directory, so we'll say /node, and we'll export our string node. Let's create our var assign. Goodness. So our variable assign and our variable access nodes, so that we can define our variables. And yeah, so var assign node, which I'm just gonna say, gonna quickly just get the node. Var assign node extends node. Okay, I'm gonna grab that and do the same thing for the var access nodes. Var access node. So now var assign and var access. So let's start off with the var access node. This is going to take in a var name token, which, you guessed it, is going to be a token. Oh, we need to set the var name token. That would be a good idea. And then we'll say pos end this dot var name token dot pos end. Okay, now our var assign node, which will take in a var name to node. So we'll set our var name token to the var name token, our value node to the value node, position start, this position start, and Same with the end, but for the value node. So that's how I would set up this. Okay, how are we gonna do this? How are we going to set up function or definitions for variables? I know I'm going to detect strings in here, so say if token.type is equal to the token type of a string, we'll register an advancement, and then we'll advance. Then we'll just return rest.success string node new string node token. So this means we are going to require that string node. Same goes for our var access and our var assign. Now our var access and assign nodes are going to be, well, the var access one is just quite simple. If the token type equals to the token type of an identifier, we'll register an advancement and advance. Then we'll return success with a new var access node passing in that token. Now our var assign node is going to look for the keyword. I mean, I did add a power operation, didn't I? You know what? Let's just quickly I don't know. Let's just extend off of this with our power operation. So in our token types, we do have a power operation, which did we use in our Alexa? Let's have a look here. We did not. Okay, let's add the power operation to this. We'll just use that. Tokens.append new token type dot pow null this dot position, then we'll advance. We can use this now in our parser. we're gonna go ahead and we're going to create a new function called atom. Yay! And basically we'll take all of our factor code and put it in there. Very easy. But instead of having this plus or minus, we'll take that out, which means we're going to need to take out this else if, and we'll take this and we'll go ahead and we'll just say that, and then we'll return this dot power. Now power is going to be power return the bin operation node, passing in the atom binded with this, and we're gonna pass in the token type of the power, and then this dot factor, which means we need to update our bin operation function to take in function A and function B. If there is a function